Section 5.2, the trigonometric functions with the unit circle approach. So remember that when we say unit circle, we mean a circle with radius 1. So, radius 1 circle here, it's a unit circle. The deal is that if I want to find points on this circle, notice that anything that's on the circle is a point, but specifically, I can find all the quadrantial angles. Okay, and so right here we have the 0, 360. Here we have the 90 degrees. Here we have 180 degrees. Here we have 270 degrees. And here we have 0 and 360 again. Okay, so if I want to know what is the point at each one of the quadrantial angles, if theta is 180 degrees, then P is going to be negative 1, 0, right? That's the x-coordinate and the y-coordinate right here for a rotation of 180 degrees. Okay, just like this will be for 90, this will be for 270. And this will be for 0 and 360 degrees. And then remember also we can talk about these things in radians. Don't forget about radians. Well, if theta is 270 degrees, what's that ordered pair? Well, it's going to be 0, negative 1. What about when theta is 90 degrees? Then P is going to be 0, 1. If theta is 360 degrees, then P is 1, 0. If theta is 0 degrees, then P is also 1, 0. Now remember that if theta is negative 90 degrees, that's actually a clockwise rotation. And since it's a clockwise rotation, it's going to go this direction, and then that is the same as negative 90 degrees. Okay? So then the ordered pair is 0, negative 1. Then we can talk about the 6 trigonometric functions that are going to be important to us. So, they are sine of theta, abbreviated sin of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Now that we have these, the way we write this is a function. And technically, sine is an operator, and then theta is what we call an argument. Argument is the thing that goes into a function. So something we might already recognize is if I had the square root of 4, square root is the function. 4 is the argument. You're taking 4 into the square root. So sine, cosine, tangent, cosecant, secant, cotheta, and cotangent, they are functions that take in a value. It's not multiplication. Alright, but now that we have the shorthand notation, let's actually define them and know what they are. Well, I claim that if we have the unit circle, remember that the unit circle has a radius of 1, then I'm going to get these definitions for specifically the unit circle. Alright? They are sine of theta is going to equal the y-coordinate of that point. Cosine of theta is going to be equal to the x-coordinate of that point. Tangent of theta is going to be equal to y over x. And then cosecant of theta is actually going to be what's called the reciprocal of sine of theta, so it's going to be 1 over y. Secant of theta is going to be equal to the reciprocal of cosine of theta, which is just going to be 1 over x. And then cotangent of theta is going to be the reciprocal of tangent of theta, which is now going to be x over y. Now something to note, and this is just to remember stuff about functions. Functions, well, arithmetic, we can't divide by 0. We don't have a definition that holds. And so there are some restrictions on each one of these, and that is that the divisor cannot be 0. Alright, now we have the definition of trig functions on a unit circle. Well now, if you want, you can use your calculator. What matters is that if you're using your calculator to verify these quadrantial angles, make sure that you're correctly in degrees or radians. But if you have your calculator with you, I'm just going to run through these, pause, and check yourself. But remember that if nothing else, if you want to do them from memory now, you have 0 degrees, which is also 360 degrees, 90 degrees, 180 degrees, 270 degrees, and that gives you the ordered pairs 1, 0, 0, 1, negative 1, 0, 0, negative 1. And so to verify what they are in your calculator, sine of 180 degrees is 0. Cosine of pi is negative 1. Sine of 360 degrees is 0. Cosine of 2 pi is 1. Sine of 3 pi halves is negative 1. Cosine of 270 degrees is 0. Sine of 0 degrees is 0. Cosine of 0 degrees is 1. Sine of 90 degrees is 1. Cosine of 90 degrees is 0. Sine of negative pi halves, well, remember that's a clockwise direction, but since we're checking in the calculator, that's going to be negative 1. Cosine of negative 90 degrees is 0. Now, if you didn't get any of those right, make sure that you have your calculator in degree mode or radian mode when you do degrees or radians, because your calculator has to know which one you're plugging in. Continuing using this definition, we know our definition on a unit circle. So, if we're told that this value P is a point that corresponds to a central angle T on the unit circle, well, just to get it all together, it's going to look like this, just for the sake of argument. Pretend that my circle actually is perfectly round. The radius is obviously 1 because it's a unit circle, and my picture is wrong because negative 1/5 2 root 6 over 5 is actually going to be over here because that coordinate's got to be in the second quadrant. Then I know that I have a point, and that point is negative 1/5 2 root 6 over 5. Now that we have these definitions, let's find sine of t. Well, that's going to be 2 root 6 over 5. Then cosine of t, well, that's the x value. That's just going to be negative 1/5. Tangent of t is y over x, so that's going to be 2 root 6 over 5 divided by negative 1/5. But this is fraction division that turns into fraction multiplication, so 2 root 6 divided by 5 times the reciprocal of the denominator, negative 5 over 1. 5 divided by 5 is 1, and then the negative times 2 root 6 is negative 2 root 6. Remember that cosecant of t is the reciprocal of sine, which is 1 over y, and so that's going to be 1 over 2 root 6 over 5. But someone might want us to clean this up, so that's going to be multiplied by the reciprocal, 1 times 5 divided by 2 root 6. And then that's going to be 5 over 2 root 6. But if someone wants to rationalize, remember that to rationalize, you've got to multiply by 1 in disguise. That's the square root of 6 over the square root of 6 for this one, and then it's going to be 5 root 6 divided by root 6 times root 6 is root 6 squared, which is 6. 2 times 6 is 12. So we have 5 root 6 over 12. Secant of t is going to be 1 over negative 1/5. And then, of course, we can clean that up. That's 1 times the reciprocal, negative 5 over 1. But that's just going to be negative 5. Cotangent of t, that's going to be negative 1/5 divided by 2 root 6 over 5. Fraction division is fraction multiplication, so that's negative 1/5 times 5 divided by 2 root 6. 5 divided by 5 is 1. We're left with negative 1 over 2 root 6. If we need to rationalize, that's times root 6 over root 6. Then that's going to be root 6 divided by root 6 times root 6 is root 6 squared, times 2 is 12, so root 6 over 12. Now that we can use this definition, we can fill in a lot of this chart, all right? So we're going to fill in the white space right now. The shaded space will come later. And let's remind ourselves of the definition since we'll start learning this. Sine of theta is y, cosine of theta is x, tangent of theta is y over x. Now if you're trying to remember this pretty quickly, once you get into the habit of using y, x, and y over x for the sine, cosine, and tangent, and then the reciprocals for the others, it may be useful to draw the picture. Now, I've just drawn a unit circle here, but the deal is that if I remind myself where the angles are, I can find the values pretty quickly. So if this is 0 degrees, this is 90 degrees, this is 180 degrees, this is 270 degrees, and then of course we wrap back around to 360 degrees. Well, once we've got all this going on, what happens? You've got the ordered pairs that line up. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And since I have these definitions, we can pretty much quickly fill them in. Now back to remind ourselves what the radians are in degrees. Well, 0 degrees is 0 radians, 90 degrees is pi halves radians, 180 degrees is pi radians, 270 degrees is 3 pi halves, 360 degrees is 2 pi, 30 degrees is pi sixths, 45 degrees is pi fourths, 60 degrees is pi thirds. Now back to the quadrantial angles. Now we can find the quadrantial angles for all 6 of our trig functions. Sine of 0 is 0. Sine of pi halves is 1. Sine of pi is 0. Sine of 3 pi halves is negative 1. Sine of 2 pi is 0 again. Cosine of 0 is 1. Cosine of pi halves is 0. Cosine of pi is negative 1. Cosine of 3 pi halves is 0. Cosine of 2 pi is 1. Once again, I'm just looking at the ordered pairs as I wrap around here. Tangent of 0 is 0. Tangent of 90 degrees, we have to be careful because remember, we can't have our divisors be 0. And so here, when we have y divided by x, the fact that at 90 degrees, y is 1 and x is 0, we get a 0 divisor, and so we then have undefined. And so remember that anytime our ordered pair in the denominator is 0, undefined. Can't divide by 0. Tangent of pi is 0. Tangent of 3 pi halves is undefined again. Tangent of 2 pi is 0. Then, same thing, but now we're dealing with reciprocals. So cosecant of theta is 1 over y. Secant of theta is 1 over x. Cotangent of theta is x divided by y, looking at the ordered pairs as I wrap around on my unit circle. Cosecant of 0 degrees is undefined, right? Cosecant of 90 degrees is 1. Cosecant of 180 degrees is undefined. Cosecant of 270 degrees is negative 1. Cosecant of 360 degrees is undefined. Secant of 0 radians is 1. Secant of pi halves is undefined. Secant of pi is negative 1. Secant of 3 pi halves is undefined. Secant of 2 pi is 1. Cotangent of 0 degrees is undefined. Cotangent of 90 degrees is 0. Cotangent of 180 degrees is undefined. 270 degrees is 0. And 360 degrees is undefined. Once again, just looking at my definitions based on the ordered pairs where we are on the angle. Now let's find the exact values of the following quadrantial angles. So once again, remember this idea is that you're taking this ray that starts at the vertex and crosses the unit circle. And then if we hold this point here and we rotate it around the circle, we want to know where we end up. So 5 pi. Well, let's remind ourselves. 0, pi halves, pi, 3 pi halves. We come back and we go 2 pi rotations. Alright, so let's follow this. Let's see what we have. If we're rotating for 5 pi, we rotate pi radians. Then we rotate 2 pi radians. Then we keep going. This gives us 3 pi radians. Then we get back over here to 4 pi radians. Then we come back around for 5 pi. So 5 pi radians ends up right there on the unit circle. That is our angle, which means that we're now looking for the y-coordinate for this ordered pair, but of course that ordered pair on the unit circle is the ordered pair negative 1, 0. So the y value for 5 pi is 0. Similarly, let's do it for negative 540 degrees, but cosine of negative 540 degrees. Alright, so our rotations, not only could they be in radians, but they could also be in degrees. But that says negative, so let's see what the negative is. So if we start at 0, and then we rotate, this is then negative 90 degrees of rotation. This would be negative 180 degrees of rotation. this would be negative 270 degrees of rotation. Then we would come back and we then get to negative 360 degrees of rotation. Then if we continue our rotations, this ends up being negative 450 degrees of rotation because we kept rotating past 360, and this would be negative 540. So let's just pretend we start with our standard position, and then we rotate in the negative direction. So let's do our theta here. So we rotate negative 360 degrees, negative 450 degrees, negative 540 degrees. That's where the terminal ray ends up. That's the point. That point ends up being the value negative 10, right? That's the ordered pair. And since cosine of negative 540 is this endpoint, where this ray crosses the unit circle here at negative 10, then we know that we take the x values for cosine, and so that's going to be negative 1. Alright, but now we have to look at these other ones that we're curious about. 45 degrees, we want to find the trig values for all of those, and 30 and 60 degrees, we want to find the trig values for all of those. Great. Well, when we're dealing with a 45 degree angle, of course, this is what a 45 degree angle would look like, right? That point P is in the first quadrant. But via my definitions, I do know that x has to be the cosine of 45 degrees, and I know that y has to be the sine of 45 degrees. This is the definition. Well, we're going to play a trick. And the trick is that because I just have this line, if I ignore the circle for a moment, I can create a right triangle. Now, if I create this right triangle, something neat happens, and I actually get the x value there, and I get the y value there in a right triangle. I know that my radius is 1 because I'm on a unit circle, and I know that x is cosine of 45 and y is sine of 45. Well, I of course get this picture. Then I know that I have a right triangle. And remember that with right triangles we have the Pythagorean theorem. But not only do we have the Pythagorean theorem, but I want to remember that when we're talking about a triangle has this property that if you add up the angles in the triangle, you're going to get 180 degrees. And so if I want to find the third angle over here, I can find that third angle by taking 180 degrees minus the 90 degrees that's in the right angle, minus the 45 degrees that's right here. And what are we left with? Well, we're going to be left with 45 degrees. Well, this actually is really neat because I know that if I have what's called an isosceles triangle, then I know that these two sides have to be equal. And so I know now that specifically for sine of 45 degrees and cosine of 45 degrees, they have to be the same. Now that's strictly because of the properties of our definitions and the properties of triangles. Well, but remember that what I've drawn here ends up being a right triangle, which means that I have Pythagorean theorem, so let's remind ourselves of that. And since that's the case, what I'm going to do is I'm going to let cosine of 45 and sine of 45 be equal to each other, since that's what I'm trying to find anyway, and then I'm going to plug them into the Pythagorean theorem and solve for x. Well, x squared plus x squared, that's 2x squared. That's equal to 1 squared, which is 1. We're just solving for x squared, divide by 2, divide by 2. X squared is equal to a half. Then I can take the square root of both sides. Yeah, I know we have to be concerned about the positive and the negative when we take the square root of a square, but right now we're going to ignore it because we know we're in the first quadrant and we're safe, and so x is going to be equal to 1 over the square root of 2. Sometimes we have to rationalize, and if you need to rationalize, remember you multiply by 1 in disguise. That's root 2 over root 2, which is then going to be 1 times root 2 is root 2. Root 2 times root 2 is root 4, which means we have root 2 over 2. Well, look at that. We now know what sine of 45 degrees, what cosine of 45 degrees, and not only that, we also know that that ordered pair, that point that we have, has to be the ordered pair root 2 over 2 for the x-coordinate, root 2 over 2 for the y-coordinate. Now, at this point, We know sine of 45 degrees, we know cosine of 45 degrees, and then we can take the reciprocal of each one of those to find the secant of 45 degrees and the cosecant of 45 degrees, or of course of pi halves. And then the only thing left to deal with is tangent of pi fourths. Tangent of pi fourths ends up being what? Well, that's going to be x over y, right? And if x is root 2 over 2, and y is root 2 over 2, root 2 over 2 divided by root 2 over 2, anything divided by itself, that's 1. So the tangent of pi fourths is 1. And then the cotangent, which is the reciprocal of tangent of pi fourths, that's going to be 1 as well. And so there we are. We have the exact values for all of the trig functions for 45 degrees or pi fourths radians. We can do sine of pi fourths times cosine of pi minus sine of 3 pi halves. Well, all we need to do is just use our definitions, find these things using the unit circle that we've got going on and those exact values for pi fourths, and we can do the arithmetic and be done. So what is sine of pi fourths? Sine of pi fourths is just root 2 over 2. Cosine of pi is negative 1. Negative sine of 3 pi halves, well, that's negative whatever sine of 3 pi halves is, which is negative 1. And then we can just do the arithmetic and clean up. Root 2 over 2 times negative 1 is negative root 2 over 2. And then minus 1 is plus 1. And if you wanted to combine, you could by getting common denominators, multiply by 1 in disguise. That's going to be 2 minus root 2 divided by 2. And there's our answer. That's the exact solution. But now we need to find the last sets, 30 and 60 degrees. Well, first I want to start with that similar trick that we did earlier. What did we do? We tried to figure out what x and y were. And so that's going to look like this, right? Well, when I bring that right angle down, then I've got, of course, my x value, which is going to be cosine of 30, and my y value, which is going to be sine of 30. Great, that's fine. Then I'm going to think about that other angle here. Remember, add up all the angles in the triangle. You're going to get 180 degrees, so 180 minus 90 minus 30, that leaves this to be a 60-degree angle. Well, why is that useful? Well, there's a neat little trick here where if you mirror this triangle down, make another right triangle, well, this one's also got to be 30 degrees because we just mirrored it. And this one's got to be 60 again because we just mirrored it. And then now we have 30 degrees and 30 degrees. 30 plus 30 is 60 degrees. 60 degrees, 60 degrees. Which means that we have an equilateral triangle. And since we have an equilateral triangle, noticing that 30 degrees plus 30 degrees is 60 degrees, then this right here has to be 1. Since that is 1, I know that y plus y has to equal 1, which means that 2y equals 1, divide by 2, divide by 2, y is equal to 1/2. Well, since I know that y is equal to 1/2, I now know that sine of 30 degrees is equal to 1/2. I'm going to look at just one of these triangles. I don't need both of them this moment. I just need to find whatever x is. Now that I know that y is really 1/2, I again can use the Pythagorean theorem. So that's going to be x squared plus 1/2 squared is equal to the hypotenuse 1 squared. Well, x squared plus 1 squared is 1, 2 squared is 4 is equal to 1. Then I can just solve for x minus a fourth minus a fourth. Then I get that x squared is equal to 3/4. Take the square root of both sides. X equals root 3 over 2. And since x equals root 3 over 2, now we know that cosine of 30 degrees is equal to root 3 over 2. So that technically means that we can now find all of our answers for sine, cosine, tangent, and their reciprocals of pi 6 or 30 degrees. Well, how do we get to 60 degrees? Well, the truth is that if you do that rotation to 60 degrees, then that ordered pair just flips because now you have that other triangle and we're just playing with geometry, and so that means that the ordered pair for the 60-degree angle is actually going to be 1/2 root 3 over 2. Then, since I have the two ordered pairs now, I can use that information to get the rest of them. Now we can find the exact value for the following. If I have the tangent of pi fourths, well, what is the tangent of pi fourths? That's going to be 1 times sine of pi sixths, well, that's going to be 1/2, minus final solution. Well then, once we have all of that, we can use a little bit of reflections and rotations to get the rest of the useful ones. So notice that really, if I want to flip this one, it's the same as that one, right? And so you're just going to change the coordinates based on where you are. So instead of being positive 1/2, it's going to be negative 1/2 root 3 over 2. And then root 2 over 2 and root 2 over 2, they're going to become negative x values. So that's now negative root 2 over 2 root 2 over 2. Same with the next one. Flip it across over here. That root 3 over 2 is going to become negative because you're on the negative side of the x-axis. And then you can bring these down, but when you come down across the x-axis, that reflection across the x-axis changes the y value to negative. There, and there, and there as well. Then we flip back over to the right. We're going to do our reflections again. And since we're reflecting these, signs change again, and we've found the important xy coordinates on each one of the iterations of these angles all the way around the unit circle. And so now we can really answer what are the 6 trig functions of any of these angle measurements. Now let's use a calculator to approximate the following values. What's going to matter when you're using your calculator with trig functions and approximations is that your calculator is in the correct mode. We have degrees as an angle measurement now, we have radians as an angle measurement, and your calculator has to be told which one you're working in. So notice that our first one is the cosine of 15 degrees. So look at your calculator, look at the bottom right hand corner of the screen. You should be in DRG mode. Once you check and confirm that, then you hit cosine, 15, enter, and if you round it 2 decimal places, you'll get 0.97. Now you need to change it to radians. So hit the DRG button at your calculator, click over to RAD, hit enter. Now you're in radian mode. Confirm by looking in the bottom right hand corner of your calculator for RAD. Now type in tangent, pi divided by 12, close parentheses, enter. That's approximately 0.27 when rounded to 2 decimal places. Now we want to approximate the secant of 10. But this is problematic because if you notice, there is no secant button on your calculator. None of the reciprocal functions are on your calculator, but they are reciprocal functions. Just to call attention to, cosecant of theta is the same thing as 1 over sine of theta. Secant of theta is the same thing as 1 over cosine of theta. And cotangent of theta is the same thing as 1 over tangent of theta. And so working with approximations of our reciprocal functions, those are the things to remember. Then the secant of 10 is really going to be 1 divided by the cosine of 10. And so 1 divided by the cosine of 10 in my calculator is approximately negative 1.19. Well, after all of this, you can definitely generalize our unit circle definition to a circle with any radius r. And so we're not going to fix it with a radius 1 anymore. Given any circle centered at the origin on an xy coordinate plane, then I can find the values of any trig function based on the rotations of theta when rotating from standard position by finding sine of theta is equal to y divided by the radius r. Cosine of theta will be equal to the x coordinate divided by the radius r. Tangent of theta is going to be equal to the y coordinate divided by x coordinate. Cosecant of theta is the radius divided by the y coordinate. Secant of theta is going to be the radius divided by the x coordinate, and cotangent of theta is going to be x divided by the y coordinate. Now let's try this in practice. We want to find the exact value of each of the 6 trigonometric functions of an angle theta where 3, -4 is a point on the terminal side of that ray. So I would say, let's sketch it. XY coordinate plane, got an origin there. Then finding 3, -4, that's going to be 3 to the right, down 4, somewhere in this vicinity. So this is technically our terminal ray. If that's our terminal ray, realize that the circle should have that equivalent radius throughout, and so that's the point 3, -4. Well, at this point, you can get a triangle by coming down here to the x-axis. There's the right angle. Now, why have I done that? Well, let's look at it blown up. This is the triangle. Now, I didn't sketch it, but I should have. That is my angle theta, right? So that's the angle theta. There's the right angle. But the ordered pair 3, -4 lines up with the lengths of these triangle sides. So the x value is 3, the y value is -4, and then I can find my radius r using the Pythagorean theorem, which is 3 squared plus -4 squared is equal to r squared. Solve for r. 3 squared is 9, plus 16 is equal to r squared. 9 plus 16 is 25, equal to r squared. Take the square root. Radius is going to be positive for us, so r is going to be positive 5. Using the definitions of our generalization, sine of theta is going to be y divided by r. The ordered pair x, y was given to us, right? And we found the radius r, so y is -4, r is 5, so -4/5 is my sine of theta. Now, for free, you get the cosecant of theta because it's just the reciprocal, 5 over -4. Then, cosine of theta, well, that's going to be x over r, so that's going to be 3/5. Secant we get for free, that's the reciprocal of cosine, that's 5/3. Then tangent of theta is, of course, going to be y over x, so that's -4 over 3. And then we get the cotangent for free, that's the reciprocal, 3 over -4. So be careful. If it doesn't say unit circle, you probably have to find some missing value. Now for a trick to help you find all of the exact values of all 6 trig functions. So what we're going to do is take your left hand, make it look like this. So match up with me. Thumb up, pinky out. We're going to create an artificial xy axis. So that xy axis is like this. Well, then what's going to happen is the other 3 fingers between your thumb and your pinky are going to represent our other nice angles. 30 degrees, 45 degrees, 60 degrees. Now, of course, remember that they are equivalent to their radian measures. Then, what we get is this idea that if you put the root over the fingers, we're going to figure out which ones to count, over 2. I claim you can answer what is sine, cosine of all of these angles. So, to find the sine value, you're going to hold down the finger that represents the angle you want. All right, let's give this a shot. Let's find the sine of 30 degrees using this hand trick. Okay? Well, we're going to put down the finger that represents 30 degrees. So, your ring finger. Then, count the number of fingers below the bent one. Well, I only have 1 there. So, that's going to be square root of 1 over 2. And if you look back, the sine of 30 degrees is a half. This works for all of these angles by doing exactly what we just did. Count the fingers below the angle that you're looking for, put that under the square root, put it over 2, and you have found the sine of each one of those angles. Then let's try the cosine. So for cosine, let's do cosine of 30 degrees. Well, cosine of 30 degrees, you're going to bend down your ring finger again, because that's representative of 30 degrees, and count the fingers above the bent one. Well, now there's 3 fingers above the bent one. At this point, what do we get? We get the square root of 3 divided by 2, and that is exactly cosine of 30 degrees. Once again, this works for all of the angles that we have listed here. In addition to that, you can also use this trick to find the tangent values. Let's try to find the tangent of 60 degrees. Tangent of 60 degrees, put down your pointer finger, and then you're going to take the square root of the bottom fingers, so the bottom fingers are 3, so that's going to be square root of 3, divided by the square root over the top fingers, so that's 1, square root of 1, and so root 3 over root 1 is root 3 over 1, or square root of 3. And so this is just a nice, neat trick to help you get through all of these exact trig values. Now I'm just going to give you the trigonometric functions defined in terms of an acute triangle. And so this is just for your handout so that you have all that information consolidated in one place. But if I superimpose a right triangle, here's the right angle. That of course makes the side opposite the right angle the hypotenuse. And then since I have this rotational theta, the side opposite theta is opposite, the side closest to theta is adjacent. Then I can define my trig functions in this fashion as well. Now, you don't need to know this right this moment. We'll talk about it when it's important. But it was just so that you had the comparison. Some people will actually use SOHCAHTOA to help remember these things. But the unit circle works just as well.